Hi, and welcome to AP Chemistry Exam Review with me, Dr. V, and it's time to go through a free response question from an old AP exam. In this webcast, we're looking at free response question number 4 from the 2021 exam. If you're familiar with the structure of the AP Chemistry exam, and you probably are at this point, you should know that free response question number 4 is one of the short free response questions, and that means it's scored out of 4 points total. You'll want to get your calculator and your periodic table and your AP Chemistry equation sheet and have them handy, because what I want you to do is listen to me present the problem and then pause the webcast, try to answer it on your own, and then listen to my solution. That's really what's going to help you improve as a chemistry student. And then you can keep track of your score as you go and decide, did you earn the point, did you not earn the point, and what could you do to enhance your answer. All right, let's jump right into the problem. A student investigates a reaction used in hand warmers represented above. The student mixes solid iron with a catalyst and sand in a small open container. The student measures the temperature of the mixture as the reaction proceeds, and the data are given in the following table. So here's the setup for the problem. Looks like it's going to be a calorimetry problem because it's about heat changes. The mixture of the solid iron, the catalyst, and the sand has a total mass of 15.0 grams and a specific heat capacity of 0.72 joules per gram per degree Celsius. Calculate the amount of heat absorbed by the mixture from 0 minutes to 4 minutes. So we've got a heat change that's Q equals mc delta T. That's the equation that we need to use here, where m is the mass of the mixture, C is the specific heat of the mixture, and delta T would be the temperature change for the first 4 minutes. Because what we want to do is find the temperature change based on the maximum temperature that was recorded, which was at 4 minutes. And so delta T is the temperature at 4 minutes minus the temperature at 0 minutes. It's always T final minus T initial. So we are going to have a positive number for delta T, and we're going to just substitute those values in, and we get a delta T of 17.7 degrees Celsius. We know the mass, we know the specific heat, we know delta T, substitute and evaluate. So we plug those values in, and I get a value of 190 joules for Q. I do want to report it with 2 sig figs because the specific heat was known to 2 sig figs, and so that's why I'm going to write it as 190 joules, no decimals. And this was worth 1 point. And now we're ready for part B. Calculate the mass of iron in grams that reacted to generate the amount of heat calculated in part A. So we do need to use our answer from part A, and our answer for part B needs to be consistent with that. We've got the balanced equation, and we know delta H for this equation. So we've got this thermochemical equation, and we know from part A that Q was 190 joules. So we're going to just worry about the absolute value of Q here. We have a mass-energy relationship from the balanced equation, and that's really the key. We know that for every 4 moles of iron that react, 1,650 kilojoules are generated. And so we just need to set that up with factor label. Dimensional analysis can be your best friend. We do need to make sure that we convert our joules from part A to kilojoules because our delta H was in kilojoules. And then we can use our mass-energy relationship, and then we use the molar mass of iron to get our final answer. Altogether, this was worth 2 points. The way I interpret it, it was 1 point for figuring out the energy to moles of iron relationship and using that properly, and the other point was for then calculating the mass of iron needed correctly. And there is a third part to this question. In a second experiment, the student uses twice the mass of iron as what we calculated in part B, but the same mass of sand as in the first experiment. Would the maximum temperature reached in this second experiment be greater than, less than, or equal to the maximum temperature in the first experiment? Justify your answer. I'm going to argue that delta T will be larger in the second experiment than it was in the first experiment. How do I back this up? That's really critical here. If I'm going to use twice the mass of iron, I'm going to have twice the amount of heat released. In other words, Q doubles, however you choose to say that. Now we're told in the problem that the mass of the sand is the same, but we use twice as much iron. And that means the total mass of the system is only going to increase by a tiny amount compared to the first experiment. It was an extra 0.026 grams of iron. So it's still going to be just a little over 15 grams. We know from Q equals mc delta T that the temperature change is going to be proportional to Q. Since Q doubled, delta T also has to be larger. This part was worth 1 point. You had to have a correct answer that delta T would be larger and back it up with an appropriate explanation. A reminder, lead with the answer with these kinds of questions and then give your justification. And that's why I set it up. Delta T will be larger, and then I explained why. That's the safest way to show your answer here. So how did you do? When this question was done in 2021, the average score was 1.22 out of 4 points total. So that's about 30%. If you understand calorimetry, if you can do Q equals MC delta T, you've done some calorimetry experiments, it's really a very accessible question. So if you earned 2 points on this question, you're doing just fine. If you earned 3 or 4 points, you should be very pleased with your performance here. If you found this video to be helpful, like the video and leave a comment, and subscribe to my channel so you get all my latest updates. Keep practicing chemistry every day, do lots of problems. That's the key to getting better.